Okay, so this question is using sequences, and we're told that it's n number of years that a university has been open, and then they've collected the information on the amount of applications they've received per year. So we have the first two terms essentially of the sequence, and we're calculating the percentage increase in those applications. So if it's the percentage increase, so this is part A, then we do the new value minus the old value to find the difference between them. So 12669 minus 12300, so that finds the difference, and that's all divided by the old value or the original value. So that is actually in your formula book to use as well. And if we times that by 100, that will give me a percentage. Okay, so if you do that, then you find that you get 3%. Okay, so it's a 3% increase each time. Then the next part is using it as a sequence. So it's assumed that that number of students will continue to follow a geometric sequence. So it continues in that same pattern, and we need to write down the common ratio. So the common ratio of that sequence is increasing it by 3%, which means that it will be 1.03, which is the multiplier to increase by 3%. So that's 100% plus the 3%, so therefore 1.03. And then the next part of the question is asking us to find an expression for the sequence. So an expression for the sequence, if it's geometric, is going to follow the rule un is equal to the first term times the ratio to the power of n minus 1. So when we're working the specific one out for our sequence, we know that the first term is 12,300. So that's told to you in the first part of the box there. And that's to be times by the common ratio, which is 1.03 to the power of n minus 1. And then we're using that in part 3 to find the number of applications in the year n is 11. So now we're just substituting in when n is 11. So it's 12,300 times by 1.03 to the power of 11 minus 1. Or you could just write to the power of 10. And you'll need to put that one into your calculator, and you'll find that that gives you 16,530. And then it says that in the first year, there were 10,380 places at the university that are actually available for those applicants. And they're going to increase by 600 a year. So this time we're adding 600 every year, which represents a sequence, and we need to again find the rule for that sequence. Now, if we are adding 600 each year, this is going to be an arithmetic sequence. So the first term is that 10,380, and then we're going to add 600 to that. So the next term is 10,980, and so on. So we're adding 600 to each term. So that tells us that it's an arithmetic sequence. So for the first part there, we're writing down an expression. Now an arithmetic sequence has the rule the first term plus n minus 1 lots of the difference. So the first term is 10,380, n minus 1 lots of the difference, which is 600. And you can simplify that, you can expand it. You don't need to, you can actually just leave it like that. And then for the first 10 years, all places are filled, and students who receive a place pay $80 acceptance fee. Calculate the total amount of fees paid to the university. So for this one, we're finding the sum of the arithmetic sequence. We want to find out how many people actually attended over those 10 years. So we're adding together how many attended the first year, how many attended the second year, the third year, the fourth year, and so on. So it's the sum of the, now my notation I should have used V for this one rather than U, which is the notation they've used in the exam. So it's the sum of the sequence V. Whoops. The sum of the sequence V, and we want to find the sum of the first 10 terms. Okay, don't worry too much about notation there, but it's going to be using your arithmetic summation formula, 10 or n divided by 2 lots of U1 plus n minus 1 lots of the difference. So 9 lots of the difference, which is 600. Okay, and again, you can just type that into your calculator. And we also know that we want to get 80 times that. Okay, so each person that attends the university pays $80 for the entrance fee. So whatever the answer is to that part, we want to work out 80 times it. Okay, so on the calculator, this first part is equal to 130,800. And we want to times that by 80, because that's how much each fee costs. And that gives me 10,464,000. Okay. And then for part E, it says that when n is equal to k, so there's obviously this value of n, where the number of places for the first time exceeds the number of students who apply. And we need to find where that k value is. So there's different ways of working this out. You could use the algebra, or you could use a graph, okay? So I'm going to show you the graphing method first. We're trying to find out, essentially, where are the two sequences equal to each other, so that we can then start to think about when is it that one of them is going to be bigger than the other, okay? So the first sequence, we've already written down that the rule of it, and this is the number of people applying, is 12,300 times 1.03 to the power of n minus 1. And we're trying to essentially work out when is that equal to the number of places available, which we've written down is the arithmetic sequence 10,380 plus n minus 1 lots of 600. So if I then go to my GDC and open up the graphing software, I could plot both of these. The only thing is I need to remember that when I'm plotting them, I need to write it in terms of x, so x to the power of n minus 1, so it's to the power of x minus 1, and then that will plot the original graph for me. Now I'm going to need to zoom out significantly so that I can see what the graph might look like. Okay, so we can start to see a little bit here. And then I need to plot the second one, which is 10,380 plus n minus 1 times 600. And again, I need to remember it's not n, it's actually x. Okay, so here we've got the second graph. And you can see there that there's a value where they're both going to be equal to one another. Okay, so it's just about here. Let's move these out of the way. So I can now find that by doing analyze and finding the intersections. Whoops. Okay, and you can see that it happens at 12.5. So it happens when x is equal to 12.5, or when n is equal to 12.5. And therefore, we can see that the red line, which is the number of spaces available, overtakes the blue line at that point. Okay, So n is equal to 12.5. So it can't happen before 12.5, and there isn't really a 12.5 term. So the first value of n where it's bigger is actually when n is equal to 13, and therefore k is equal to 13. Now you could also do it using your algebra. So you can solve this part here. You can type that into nsolve, and that would give you the answer as well. Either of those methods would be fine, okay? And then for the last part, we're stating whether for all n is bigger than k, the university will have more places than applicants, okay? So will they always have that? And there's not a guarantee for it, because it's a geometric sequence. So actually, a geometric sequence will eventually get bigger and bigger and overtake it. So you can see here, there's actually another intersection here, okay? And you can see that a geometric sequence will generally go faster than an arithmetic, okay? So there's not enough evidence. You could draw the graph to show that, or you could find that intersection and say, well, actually, after this point, we can see that there's not enough evidence, okay? So either of those methods would be fine.